Okay. Now, as soon as you have figured out that it's arithmetic, then you have narrowed down your formulas. The arithmetic formulas are these, and you need to know that. You need to know these are your arithmetic formulas, right? So then the next question you ask yourself is, once you figured out it's arithmetic, it's going to be one of those two formulas for this problem right here. The next thing you ask yourself is, am I looking for a sum or am I looking for a term? What does sum mean? S-U-M, what does that mean? I'm adding them all up. Anything in this problem indicate I'm adding them all up? Is that an S? Nope, that's an A. So I am looking for the 93rd term. So I will use this formula, right? And it's just plug and chug. So I want to find A sub 93. Don't be confused by that. You'll frustrate me if you're confused by that. A sub n. A sub 93. N is 93. So I have my first term plus my common difference times 92. Where did the 92 come from? N was 93. So n minus 1 is 92. I take out my trusty calculator, and what is that, 280? And that's the answer to the question. Easy. All right, let's look at this one. First thing you ask yourself is, what? Arithmetic or geometric? What is this one?
Geometric.
Geometric? Within ratio of? 1/2. Aren't we multiplying by a half? All right, so your geometric formulas are these. And we gotta figure out which one to use. It's geometric, so it's one of these. How do we figure out which one it is? It's a sum. It says right there, S sub 20. So the formula says S sub 20 is the first term minus the first term times the common ratio 2 to 20th over 1 minus the common ratio. What am I doing? Just plug in numbers into the formula, right? Not hard. Now, this is the formula. I always like to do my denominator. So what's 1 minus a half? 1/2. I'm going to make it 0.5 because that's easier for me to type in on my calculator. The denominator is 0.5, 1 minus a half. And then I just type in the numerator, hit equals, and I get my answer, which is 15.99998. Is that what you got?
Mm-hmm.
Not quite 16, but it looks like it's getting close. We'll talk about that today. All right, number 3. First question you ask yourself is, what have I got? What do we have here? Arithmetic with a common difference of 6. So I'm going to use one of my arithmetic formulas. That's these right here. And since the problem very clearly says S sub 88. I'll be using this one.
Yep.
So S sub 88 equals 88 over 2 times the first term, A sub 88. 88 over 2, first term, 88th term, A sub 88. What's the matter? Do I know that? So we talked about this. What do I do when I don't know, when I don't have something I need? I use the other formula. I find A sub 88. So A sub 88, still arithmetic, so I'm still using my arithmetic formula, equals the first term plus the difference times 87. Is that the answer then? Am I done? Can I write that down and move on? No. That is this, right? So I gotta add 10 to that. And multiply basically by 44. So I got 23,848. Okay? Last one. A sub 12. Well, what kind of sequence do I have? Geometric with a ratio of 3. My geometric formulas are these. I'm not gonna label this for you. You need to know which one's which. These are your geometrics. They have all of them in them. That should be clear. Which one do I use? The top one or the bottom one? Look, what's it say? A sub 12. So you're using A sub 12. So A sub 12 equals 9 times 3 to the 11th. The big one. $1,594,323. Okay? Now, I don't see you tomorrow, but I see you on Wednesday. Guess what's gonna happen on Wednesday? You're gonna have a quiz. And the quiz is gonna be just like this. Right? I'm gonna give you the formulas. I promised I would always do that. I'm not gonna tell you which one is which. So you're gonna have to figure out which formula to use and do the problems. Got it, friends? Okay. Let's get our notes out then and we'll maybe wrap it up. Alright, this is kind of a wild concept, but you can actually add up infinite things as long as they are geometric. They have to be geometric, and their ratio has to be less than 1. So So again, what does that mean? If the ratio is less than 1, what does the fraction look like? 1/2, 1/3, 1/5, 2/5, something like that. So as long as that's your ratio and it's geometric, you can add it up. The formula for doing that is this. Notice that there is no n, there is no n in this formula. Because if you are infinite, what does that mean? There's no counting, right? You can't say I want the 100th term or I want the 18th term. You can't do it. So there's no n in it. But you can add this up. All right? So how does this work? What does this stand for? First term, which is 3. What's my ratio? What am I multiplying by here? 1/2. So 1 minus 1/2 is 1/2, 4.5. So 3 divided by 0.5, or 3 divided by 1/2, however you do it, is 6. So that one, the answer is 6. If you kept adding these up forever and ever and ever, you would keep getting closer and closer to 6. All right, let's look at the next one. Remember, when it's dot, 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 when you're adding an infinite thing, notice it's just S, no N. When you're adding an infinite thing, it has to be geometric. So, is this geometric?
No.
What am I multiplying by?
Negative 1/2.
Negative 1/2. If I keep multiplying by a negative 1/2, then that work out? So what does my formula say? The sum is going to be the first term, which is 4, over 1 minus negative 1/2. What's 1 minus negative 1/2? 1.5? 1 plus 1/2? So 4 divided by 1.5. What's math frac that? That's 8/3. That way I don't have to round it off. So I just hit math frac, and it gave me the fraction. All right, one more. What does the formula say? I need to add these up. They go on forever. Formula says the sum is first term is 6. Figure out my common ratio, so I need to figure out what am I multiplying by? What? No. What? No. Put both your answers together and you got it. Aren't I multiplying by 2/3? Right here's the easiest place. 8 times 2, 3 times 3. You can also always tell by dividing, like 4 divided by 6, that'll give you the ratio. Here's 1 minus 2/3. What is that? 1/3. So I have 6 divided by 1/3. Which I can type in my calculator, but that's 6 times 2 is 1. So the answer is 18. So what that means is, you guys, if you kept this list going forever, and you added them all up, you would get 18. You're not going to get 18 till you get to infinity. So technically, you're never going to get 18, but you're going to get closer and closer. Remember that answer we got a little while ago that was 15.99998 or something like that? Those answers were getting closer and closer to 16. If we had kept going, we would have gotten to 16. Okay. Now we have an application of this. What does that mean? What? So it's 0.4444, and so on, right? Is that infinite? Yeah. Is it geometric? Well, actually it is. You gotta kind of open up your mind here. This would be 0.4 plus 0.04 plus 0.004 and so on. So each 4 gets an additional 0 as we go down the line. If I lined these up on top of each other, it might be easier for you to see. You see how adding those up would give me my decimal? And that just keeps going forever and ever. The ratio is 1/10. Because every time I move the decimal point one more place, and one place in decimal land is 0.1. If I were moving it 2 places, it would be 0.01, 1/100. Well, now I ought to be able to get my answer. According to the formula, this one right here, I should have the first term, which is, this is my sequence. So the first term is 0.4, and the ratio is 0.1. 0.4, 0.1, because I keep moving an additional place. What's 1 minus 0.1? 0.9. And when you have 0.4 over 0.9, you can multiply both by 10. Just move it one place. And the fraction is 4 9ths. The decimal, 0.44444, is really 4 9ths. And you just showed that right there. All right, let's try that. 0.636. What sequence is this? Like this decimal, I wrote out as a sum, adding, because that's what my formula means. I'm adding. What would that would be if I wrote it out? All right, think about this. 0.63 plus 0.0063. 0.000063. And so on. Now think about that, guys. Again, you know what this means. This means 0.63, 0.63, 0.63. If you lined these up on top of each other and added, what would that equal if you added? 0.63, 63, 63, right? That's what you need to do. You need to figure out what the sequence is that when you add it, sum gives you the decimal. As soon as you figure that out, you're home free. Because the sum is the first term, which is 0.63, over 1 minus the ratio. In this problem, the ratio was 0.1. Why was the ratio 0.1? Because I only had one repeating digit. So every time I added one extra zero, what am I doing here? Adding 2 extra zeros, so the ratio is 0.01. Because this is 2 digits, I have 2 repeating digits. So I have to have 2 zeros, and then another 2 zeros, and so on and so on. What is 1 minus 0.01? What? Not 0.9. 0.99. So 0.63 over 0.99. Remember, anytime you have a decimal over a decimal, you can move the decimal point the same amount of places. So this would be 63 over 99, which reduces to 7/11ths. On your calculator, do 7 divided by 11. What does it say? Well, because we had to round off. Yeah, there's not, it's 6-3 forever. The calculator ran out of room and rounded it off. All right, C, I need everybody paying attention now. C is a little bit trickier. Can anybody see why why problem C is trickier? There's a 1 in there that isn't part of the repeating. Do you see that? So we're going to have to separate this. We've got this 0.1. And then we've got all this repeating part. Now be careful. Some kids will say this is the repeating part. That is not right. Can you tell me what's wrong with that? They need a 0 in there instead of it. You're right. The repeating part is 0.044444 because you got to have a 0.1 in that spot. So you can't have a 4 in that spot. Can't have anything in that spot because the 1 goes there. This I can add up. Just this part right here. Can anyone tell me what the first term is? Remember, we're doing just this. Can you tell me what the first term is? What? You can't use 0. Gotta have a number. I mean, it's point. No. This isn't part of it. Just this part right here. Kids, that's 0.04 plus 0.004. Isn't that what that is? Right there. So the first term is 0.04. That's the first term. What is the ratio? Don't make this hard. How many decimal places repeat? there's 4. 4, 4, 4, 4, 4. There's 1 repeating decimal place. And when the repeating decimal place is 1 number, then what's your ratio? 0.1. Let me say this again, and this time let's have everybody like focusing in and listening. Okay? This isn't hard. If you have 1 repeating number, your ratio is 0.1. If you have 2 repeating numbers, your ratio is 0.01. If you have 3 repeating decimal places, 0.001. Okay? Now, when I look at this number, yes, there's a lot going on, but how many places are actually repeating? 1. The 4 is the only thing that's repeating. So my ratio is 0.1. What is 1 minus 0.1? 0.9. Remember, when you remove a decimal from a fraction, you have to move it the same number of places. So to remove this decimal, I'm going to have to remove this 2 places. That's going to give me 0.0. So it's going to give me 4. This one has to go 2 places, which is going to give me 90. Over here, I moved them both 2 places, and I got 63 over 99. Here, I have to move them both 2 places, but that means adding a 0 in here on the bottom. So I have 4 over 90. Am I finished? Why?
So they can be reduced.
Well, it can be reduced, but even more than that, why am I not done? What is that? That is this part. What still needs to be factored in? The 0.1. So you're going to take 4/90ths and add 0.1. What is the fraction for 0.1? Say it. How do you say that number? Other than 0.1, what does that number mean? 110. This is 110. How do I add fractions? I get a common denominator. So I have 4/90ths plus 9/90ths, which is 13/90ths. To check, take your calculator like Ronic's doing and divide 13 by 90. If we did it right, this is what it should say. All right. Sometimes these problems can be really, really easy. They're not as easy. This is a super simple one. What can you tell me about 0.3 repeating? Just the 0.3 part. What is 0.3 repeating? We really don't know what 0.33313 is. It's 1/3. 0.333 is 1/3. So this is 2 plus 1/3, which is 2 1/3, or if you like an improper fraction, 7/3. You should probably probably know that repeating 3's 1/3. What are repeating 6's? 2/3. What are repeating 9's? There you go. You got it. Well, I'm getting down my math league shirt. Because the logo for the math league shirt, look down here on motto, we are number 0.9 bar. Because repeating 0.9's don't round up to 1, they are 1. So when we say we are number 0.9 bar, what we're saying is we are number 1.
You
1/3. 2/3 is repeating 6's. So 3/3 is repeating 9's. And 3/3 is the same as 1. Alright, one more. Alright, here we go. Stay with it this Your job is to write this as a fraction. So think about what we've been discussing, and what do you think we have to do first? We'll need to break it up, because the repeating part is right here. So we've got 1.7, and then we have all the repeating part. Now, the repeating part is not 0.41. That is not the repeating part. What is the repeating part? 0.041. Very good. Why is it 0.041? Because there's a 7 in there. You can't put a 4 there. It's got to be a 0. 7's already in that spot. So 0.041. So we're going to use our formula, and we're going to add up the repeating part. Okay? So what does our formula say? To add up just the repeating part, using this formula. What's that? That's the word. We're not, this is separate. We are adding up this one. 0.041. Remember, that formula does an infinite geometric series. That's not infinite. It's not part of the series. It's there, I deal with it, but it doesn't go in the formula. What is my ratio? Alright, let me say this once again. How many decimal places are repeating? How many decimal places are repeating? 2. When 2 decimal places repeat, your ratio is 0.01. 1/100. 2 decimal places, 1/100. So 0.01. When I say decimal places repeating, doesn't this number mean 41, 41, 41, 41? That's 2 numbers repeating. That's 0.01 for the ratio. What is 1 minus 0.01? .99. To remove the decimal, we move each place the same amount. So 1, 2, 3 gives me 41. 1, 2, 3 gives me 990. You have to move the decimal the same number of places. Now, 41 over 990, I don't think reduces, but even if it does, I'm not going to because I'm not done yet. What do I then have to remember to do? Go back and add 17 tenths, 1.7, 17 tenths. So I'll get a common denominator. And that is 41 990ths plus 1683 multiplying by 99 and a common denominator. 1724 over 990. If it reduces, I have to reduce it. Is it clear to you that 2 goes into both of those numbers? Alright, so let's take 2 out. $862 over 495. Type that in on your calculator, and hopefully it says this right here. That's how we check it. All right, now, you should still have your piece of paper from when we did the practice quiz. These are not on the quiz, but I want you to practice one with your partner right now. Actually, we're going to practice two. A hard way and an easy way. On your piece of paper, I want you to change both of these into fractions and lowest terms. So use your notes. I'm going to do it too. And we'll compare notes and see how we do. Come on, everybody, let's do this. Use your notes. Remember the formula you're using. For both problems, this is the formula. But remember, that only adds up the repeating part. Simone, have you done this? Diego, was your phone in the caddy? All right, number one is definitely easier than number two. Who got a start on this first problem right here? Izzy?
I did, well, I just put it into the formula.
So you don't have to write this out, but that is your geometric sequence. That's what's happening here. You have 0.32s repeated. So what did your formula look like, Izzy?
0.32 over 1 minus 0.01.
Yep, and why did she say 0.01?
Maybe 2 spots.
2 spots repeating. So 0.01, there's 2 spots repeating. So she has 0.32 over 0.99, which is 32 over 99, because I am allowed to move. That does not reduce, so that is the answer to the question. And even if you have just a baby calculator, you can do 32 divided by 99, and it will say 0.32, 0.32, 0.32. All right, now this one was a little bit tougher. How did you start the second one? Split it. So you had to split it into 0.1. That is separate. The repeating part is 0.032, 0.00032, and so on. The formula will add that part. You have to do that separately. It's not part of the sequence. So what was that? The sum equals what? 0.032 over 1 minus, what was your ratio? Still 0.01. Because how many places are repeating? 2. It's still 32, 32, 32. So 0.01. So that's 0.032 over 0.99. Now we gotta move them 3 places. So 1, 2, 3. 1, 2, 3. 32 over 990. Now that one does reduce, but I would suggest not reducing it until you add in your 110. So you need to take 110, 110, and add 32 990ths. So we'll get a common denominator, which will be 990. So I have 99 plus 32, 131. I don't think that reduces. So I'll check it. 191, or excuse me, 131 divided by 990. Should be that right there. Okay, so now we have our 9-5 homework assigned. Let's all of us look quickly at the 9-5 assignment, which, by the way, is your last homework paper. Not your last homework ever, but your last homework paper. Number three on 9-5 says, rewrite as a fraction in lowest terms. So, you're gonna do exactly what we've been doing. Decimal is 132. Only the 3 is repeated. Do you see that? So, think about the problem we just did. What's step 1? Separate. So, 0.1 plus 0.03, 0.003, and so on. This part is addable. What's our formula say? First term is 0.03. What's my ratio? Point what? One decimal place is repeating.
0.01.
No. Point one. Point one. It's 0.01 if there are 2. So we have 0.03 over 0.9, which is 3 over 90. You can absolutely reduce that if you want. I don't usually. I'm going to take my 3 over 90 and add my 110. My common denominator is 90. So I have 3 over 90 plus 9 over 90, which is 12 over 90. Does that reduce? I need to reduce it. It does. What is it? 6 over 45. I think that reduces even more. That's 2 in the rows. I think 3 goes in the rows. So 2 over 15.
Yeah.
And of course, these are always checkable. All you do is get out your calculator and do 2 divided by 15. And what should happen? You should get your problem, right? Right? Cameron? Right? All right, that homework's due Wednesday. Let's get it done. Next time I see you, I'll hand out some review stuff.